In today's video, we'll be looking at how to solve an electric field on line charge. So the question says, find the electric field a distance z above one end of a straight line segment of length L that carries a uniform line charge. Assuming I have a line charge this way, and this is the distance from here to here, will be x, will be L, and here is x. So, and we're told there's a distance z above. So to solve this, you're going to resolve this in both horizontal and the vertical component. This is the EY, and the EX will be pointing in the negative direction. This is EX. So the total electric field E will be equal to, because this is in negative direction, it will be negative EX sine theta plus EY cos theta. So if here is ZX and this should be R, we can believe that the R is the square root of x squared plus z squared from Pythagoras theorem. So let's solve. The formula of electric field E is k integral of dq r squared r hat. So for x, we have that EX will be equal to k, but lambda is usually dq is equal to lambda dx. So k lambda, the integral of dx divided by r squared will be x squared plus z squared, and sine theta will be, sine theta is equal to this is theta, that will be opposite over hypotenuse, which is opposite x divided by hypotenuse, that is x squared plus z squared. So x divided by the square root of x squared plus z squared. So and the limit of integration will be from 0 to L. 0 to L. Let's simplify and integrate. So I can say that EX is equal to k lambda integral from 0 to L. Here is x dx divided by x squared plus z squared 3 divided by 2. So let's integrate this expression. To integrate this expression, we use the integration by substitution. We assume that u should be equal to x squared plus z squared. Then the u dx will be equal to 2x, because the integration of differentiation of x squared will be 0. So I can say that dx is equal to du divided by 2x. So substituting it back in this expression, we have ex to be equal to k lambda, the integral. This would be x divided by u power 3 divided by 2, and the x will be du divided by 2x. So now let's change our limit of integration. From here, when x is 0, then u will be equal to z squared. But when x is L, then u will be equal to L squared plus z squared. So we have this to be ex is equal to k lambda divided by 2, the integral of z squared, right, and L squared plus z squared. Then here this will cancel, then we'll be having du divided by u power 3 over 2. So let's solve further. You have that the ex is equal to k over 2, k lambda over 2. Then this is same thing as the integration of u power negative 3 over 2 du z squared L squared plus z squared. So solving further, we have that ex will be equal to k lambda divided by 2. Integration of this will be equal to a negative 2 u power half with the limit z squared L squared plus z squared. So these two can cancel, and we'll be left with ex is equal to negative k lambda. There should be negative, sorry, is u power 1 divided by u, 1 divided by square root of u z squared L squared plus z squared. Then I have this to be equal to ex negative k. Okay, let me shorten it and use the negative to enter the brackets. That will be equal to k lambda into 1 divided by the square root of z squared minus 1 divided by the square root of L squared plus z squared. So and ex will be equal to k lambda into, for this it will be 1 divided by z minus 1 divided by L squared plus z squared. This is the square root in x hat direction. So this is the electric field in x direction, but remember we have the electric field to be this expression. So we have to solve for EY, electric field in the y direction. So the electric field in y direction will be equal to k lambda, the integral of dx, divided by x squared plus z squared, 3 divided by 2, oh god, x squared plus z squared multiplied by cos theta, and this is the triangle we have. We have this here is square root of x squared plus z squared, and this is theta, here is x, this is y, this is z. So then cos theta will be equal to adjacent, which is z divided by x square plus z square. So then the limit is 0 to L. The reason why this one is I remember our electric field. The reason why I decided to like jump some steps, and the electric field is equal to k integral of dq divided by r squared r half. So this r square is this part, so and the q which we've showed before that is lambda x. So and we can rewrite this to be equal to EY is equal to k lambda z integral from 0 to L. We have dx divided by x squared plus z squared, 3 divided by 2. And to integrate this, we have to make some assumption. You can say let x be equal to z tan theta. So and if x is this, then the differentiation of x with respect to theta will be equal to z sec square theta. So dx now will be equal to z sec square d theta. If you substitute it back in the expression, we have EY is equal to k lambda z integral from 0 to L, dx is z sec square theta d theta divided by z square, or let me put it this way, divided by z tan theta square plus z square, 3 divided by 2. In our previous video, we have actually integrated something like this, so I'm not gonna do the integration. It will be a bit long. So, but if you do your integration well, you'll be getting this as your solution. Then EY will be equal to K lambda L divided by Z into L squared plus Z squared 3 divided by 2 in Y hat direction. So remember, we defined the electric field to be equal to the total electric field to be equal to negative EX plus EY, and we've gotten the EY to be this expression, and we've gotten our EX to be this expression too. So let's sum it up. So then the total electric field will be equal to, the EX is, this is negative, then EX is K lambda into 1 over Z minus 1 divided by L square plus Z square in X hat direction, and K lambda divided by Z into L square plus Z square 3 divided by 2 in Y direction. So if I decide to use this negative to open the bracket, then I'll be having my total electric field will be equal to K lambda 1 divided by the square root of L squared plus Z squared minus 1 over Z in the direction of X, and K lambda divided by Z square into L square plus Z square 3 over 2 in Y direction. So this is our final answer, which is the total electric field. Thank you for watching this video. If you have any question, you can feel free to reach us via Science eLearning Academy or nesalifa@gmail.com. So kindly subscribe to this channel for more updates.